Hello everyone, welcome to Academic Coordinates. In this video, I'm going to take you guys through the exciting world of exponents. For some of you, this video will be a revision. You know what I'm saying? However, there are still those who are going to be learning something new. So whichever group you find yourself in, just dive right in. You know what I'm saying? So when we speak of exponents, we speak of, a representation where there is a base. In this case, A is our base. And this base is raised to a certain exponent or to a certain power or to an index that is called m. So the idea here is that we multiply a by itself m times. You know what I'm saying? And then you're going to get a gist of that as you go further. There are some stuff that I want you guys to take note of, that if you've got a to the m, you multiply a times a times a. You do this m times. You know what I'm saying? Secondly, if you've got anything to the power 0, right? If you raise a number to the power 0, you know what I'm saying? You're always going to get 1. If you take yourself, raise yourself to the power 0, you're going to be 1. However, take note that a cannot be 0 because 0 to the power 0 is undefined. Then lastly, guys, one thing I want you guys to take note of is a to the negative n. So I want you to see this, that this, picture it as a to the minus n divided by 1. So now the reciprocal of this has got a positive exponent. Can you see that this n now here is positive? So basically, I wanted you guys to take note of these things. Take note though that a cannot be 0. Once again, because 1 divided by 0 is undefined. You know what I'm saying? Take yourself, divide yourself by 0, you will be undefined. So let's look at some few examples here. If we are given 5 cubed right here, what does this mean? This means that 5 times 5 times 5. You see, I've expanded this right now. You know what I'm saying? So what is 5 times 5? That is 25. Times 5 again, that is 125. Can you guys see that? The common mistake that you would see when students see this 5 cubed, they would say 5 times 3. And so this is incorrect, right? You multiply the base by itself. You know what I'm saying? And then the number of times that you multiply it by itself is going to be dependent on this exponent right here. Okay, let's continue. So the second part is 2 to the 4. So you multiply 2 by itself how many times? 4 times. So 2 times 2 times 2 times 2. So what is 2 times 2? That is 4 times 2. That is 8 times 2. This equals to 16. Can you guys see that? The third part of this exercise, you've got 5x, all of it to the power 0. Now, if you take this thing and raise it all to the power 0, you are going to get 1, right? There's not even need for you guys to sweat right here. You are going to get 1. You know what I'm saying? Even if it was 4 to the power 0, that was going to give you 1. So basically now you've got 3 to the negative 4. So take note that in some of the questions, they might want you guys to represent this with positive exponents. So this is going to be 1 divided by 3 to the 4. Do you see now that the exponent has changed from negative 4 to 4? You know what I'm saying? Okay, so what does this equals to? Let's expand the denominator right here. So this is 3 times 3 times 3 times 3. Can you guys see that? 3 times 3 is 9, times 3 is 27, times 3. This is going to be 1 divided by 81. Can you guys see that? And then lastly here we've got 1 divided by 3 to the power minus x. So this has got a negative exponent. You know what I'm saying? So now let's say you are asked to, write this with positive exponent. It's definitely going to be 3 to the power x. Do you see that? You can even put it 3 to the power x divided by 1. You know what I'm saying? So, but eventually it's 3 to the power x. Can you guys see that? Great. So now let's look at the laws of exponents. So these laws have been proven. all right? They always work. So firstly, we've got the product rule. If you've got a base, similar bases that are being multiplied by each other, and then these bases are raised to certain exponents. So this base A is raised to exponent m, this one is raised to exponent n. So now if you are in this situation where you are multiplying them, so what you're going to do, you're going to add the exponents, you know. So let's say you've got 3 squared times 3 cubed over here. So what are you going to have? You're going to write your base. You are not going to multiply 3 times 3. No. You're going to write your base, and then you're going to add the exponents. It's going to be 2 plus 5. Do you guys see that? Sorry, that's going to be 2 plus 3. All right? And then your final answer is 3 to the 5th. Excellent. So now, in mathematics, whenever you see product, think of multiplication. Right? Okay, so now we go to the quotient rule. You know, whenever you see quotient in mathematics, think of division. All right? So now it says if you've got a base here, this base is a to the power m divided by another one, which is a to the power n. Take note, these are similar bases. So what do you do to the exponents? You subtract them. So you subtract n from this one. You know what I'm saying? You subtract the exponent of the denominator from the exponent of the numerator. You know what I'm saying? So let's say, for example, you had 3 to the power 4 divided by 3 to the power, I don't know, to the power 3. So this was going to be 3 to the power 4 minus 3. So what does this equals to? 3 to the 1. You guys see that? Let's also look at the power rule. The power rule says you've got a base right here to the power a certain exponent. And then you take all of that to the power another exponent. What you do here is that you're going to multiply this m by n. Say you've got 2 to the power 7. You raise all of these to the power 2. So what you're going to do is that you're going to have 2 to the power 7 times now 2. You see that? So it's going to be 2 to the power 14. Okay. Then the power 0 is just what I explained to you guys, that if you've got anything to the power 0, you're going to get a 1. 1 to the power 0 is 1. Let's say 3 to the power 0 is equals to 1. 2 to the power 0 is equals to 1. X to the power 0 is equals to 1. You know, can you guys see that? Okay, what about a half to the power 0? We are going to get 1. Okay, take note that m should be an element of real numbers. Every m we used here should be an element of real numbers, you know. And then a should be positive and b should be positive. Let's now evaluate this. I suggest that you can do it with me. So this is supposed to be the final answer. You can pause the video if you want, and let's tackle this. So now you've got the base here, 3, even here, 3 is the base. So this is a multiplication. So you're going to write the base as is to the power what? 3x plus 4x. So the final answer is 3 to the power 3x plus 4x, that is 7x. Do you guys see that? It is that cool. So for this second question here, I'm going to, take the longer route, because I wanted you guys to sort of see the power of exponents. So 10 here, if you can express 10 in prime factors, 10 is going to be 2 times what? 2 times 5. This is still 10 right here. Then you've got x to the power 3 or x cubed. Then here you've got 5x to the power 5 right here. So what does this equals to right now? So basically, everything in the denominator, we can take it up here to the numerator. But what is going to happen is that, take note that the exponent here is 1. The exponent here is 5. There's going to be a change in the sign of the exponent, So this is going to equals to 2 times 5 to the 1. So this is this 5, but this 5 is going to be times 5 to the negative 1. Do you see now that the sign has changed? The sign has changed over here. Then multiplied by x to the power 3, which is this one, and then times x to the power 5. And take note, guys, the product rule and the quotient rule, we do that when the bases are what? When the bases are the same. Oh, sorry, take note here that this here is going to be to the negative 5. You know what I'm saying? So what is our answer? So 2 remains on its own, and then this one is going to be 5 to the power 1 plus minus 1. You guys see that? Then multiplied by x, 1 base, and then we add the exponents. Is going to be 3 plus minus 5. So this is going to be equals to 2 multiplied by 5 to the power 1 plus minus 1. That is 5 to the power 0. And then x to the power 3 plus minus 5. That is going to be x to the power minus 2. You guys see that? And then maybe if I can do it maybe here on the side. Here we've got 3 plus minus 5. So this equals to this plus and this minus multiply each other. So a positive times a negative, you're going to get a negative. So it's 3 minus 5, you see? So this is minus 2 right here. That's why here you've got minus 2. This over here, 5 to the 0 is going to be 1. So this is 2 times 1 times x to the minus 2. So if you want positive exponents, what is it this going to be? This is going to be 2 divided by x squared. Guys, see that? All right, let's continue. So now we've got 15x squared multiplied by y to the 5th divided by 5xy to the 3rd. So I'm also going to take a bit of a long route here. So how can we break 15, to its prime factors? 15 is going to be 5 times 3. Guys, see that? Then our x squared remains the same. Y to the 5th divided by 5 xy cubed. So basically, I'm taking a bit of a long route here. Okay, but anyway, and then now let us use our quotient rule, our product rule, and sort this thing out. I want you guys to take note that this 5 have got an exponent of 1, exponent of 1, exponent of 1 here, even though we don't write it, right? So now it's going to be 5. We bring this 5 on top, 5 to the 1 multiplied by 5 to the what? Negative 1 now. Then times 3 times x. So we've got here x squared, x to the 2, and then this is another x that has got the same base as the one of x squared here. So it's going to be times x to the minus 1. You see? Okay, this is still multiplying. I just ran out of space here. Times y to the 5th, which is this one, multiplied by y to the minus 3. You guys see that? Okay, so 5, let's look at this one first. This one here, it's 5 to the power 1 plus minus 1. And I showed you guys that 1 plus minus 1, this here, it will eventually be a negative, and then we times by 3 multiplied by x to the power what? To the power, looking at this one now, the bases are the same, so we add the exponent. It's 2 plus minus 1. You guys see that? And then we multiplied by y to the power 5. You see the bases are the same. We add the exponents plus minus 3. Okay, so this is 5 to the power 1 plus minus 1. This is going to be 5 to the 0. And then multiplied by 3. And then multiplied by x to the power x to the power 2 plus minus 1. What is that? That is going to be x right here. And then let's look at y over there. and then y. 5 plus minus 3 is going to be y squared. So what is our final answer? It's 3xy squared. You guys see that? Okay, cool. So let's quickly do these ones right here. So now here, take note that this that is inside the bracket, it's 5 to the power 1. Then you've got p to the power 1. Even though we don't write it, this is to the power 2. What's happening now is that this 2 is going to be multiplied by this 1 and by this 1 over here, such that this is going to equals to 5 to the power 1 times 2, p to the power 1 times 2. See that? So what does this equal to? This equals to 5 squared p squared. So this is 25p squared. See that? Okay. So now we've got this expression again. So this one, this 3 outside is going to affect all the exponents inside. You see here, the exponents can be seen. They're no longer 1. So this is going to be 3 to the 4 times 3 multiplied by 5 to the 2 times 3. You see? So this is going to be 3 to the power 12. 4 times 3 is 12. And then 5 to the power 6. Okay. Continuing now, we've got 6p to the power 0 multiplied by 7p all to the power 0. Take note, guys, that this to the power 0 here, this exponent 0 is affecting only the p. But now, the 0 here is affecting everything. So, what you're going to do is that it's going to be 6 multiplied by p to the 0 is 1 times 7p. Everything now is to the power 0. And what does that equals to? That equals to 1 as well. So what do we have here? We've got that our final answer is 6 times 1 is 6 times 1. It's still 6. Okay. Now let's look at this question. So in this question, we've got 3xp divided by 9x squared all to the power 3. So first and foremost, guys, over here, let me rather sort what is inside first. This is 3 to the power 1. This is x to the power 1. This is p to the power 1 divided by, what is 9? How can we express 9 to have, prime factors? So 9 is going to be 3 squared, and then this is going to be x squared. So all of this is to the power 3. Take note once again that this 3 is going to affect all the exponents inside, So let's do that then. This is 3 to the power 1 times 3 times x to the power 1 times 3 times p to the power 1 times 3. We divide everything by 3 to the power 2 times 3, x to the power 2 times 3. Okay, so what is it? What in the world? This is 3 cubed times x cubed times p cubed. We divide this by 3 to the power 6 times x to the power 6. So now let's manipulate our thing. So we've got 3 cubed on top, and then if we do a quotient rule here, okay, before perhaps I can do that, remember, or rather let me go the quotient rule from the get-go. So you've got this base, you've got this base right here. So the exponent is 3 and 6. So here is going to be 3 to the power what? 3 minus 6, right? And then multiplied by, we've got this x, we've got this x. So we're going to use the quotient rule. This is x to the power 3 minus what? 6 multiplied by p to the power 3. Okay, this equals to 3 to the power minus 3, x to the power minus 3, p cubed. So the final answer is gonna be, okay, this is the answer. However, let's say we're looking for positive exponents. This is gonna be p cubed divided by, so this is gonna go to the denominator, this as well, but the sign now is gonna change. 3 cubed x cubed. Do you guys see that? You can also express it like p divided by 3x all cubed. Okay, guys, let's do this one right now. So even here, guys, we're gonna, use the power rule such that this exponent is gonna be multiplied by this right here. So this is gonna be 3 to the power minus 2 times 2x plus 1. You guys see that? This equals to 3 to the power what? Minus 4x, that is minus 2 times 2x, and then minus 2 times 1 here. It's going to be like this, So this equals to what? This equals to, this is the final answer, but let's say we want positive exponents here. We're going to have 1 divided by 3 to the power what? To the power 4x plus 2. Okay, that was not really necessary, but you could have left it here. But do take note that this is the same as 3 to the power minus 4x plus 2. So these are similar, and then you can definitely take it here.